Hey everyone, and welcome back for another deep dive. You guys know we love to dig into the science behind all things fitness and strength.
Absolutely.
Well, this time we're tackling a topic that, I have to admit, really blew my mind.
Intriguing.
So one of you amazing listeners sent in this awesome video from the Institute of Human Anatomy.
Those guys always have fascinating stuff.
Right. And this one is all about getting crazy strong without getting bigger.
Oh, yeah. That's a good one. I think a lot of people assume that more strength automatically equals, like, huge muscles.
Totally. I was definitely in that camp. But this video totally flipped the script for me.
Yeah. Tell me more.
So they started by talking about this thing called relative strength.
Right. Relative strength. It's basically how much strength you have compared to your body weight.
Okay, so it's kind of like a pound-for-pound measurement.
Exactly. Like if you have two people, one who weighs 150 pounds and can lift 200 pounds, and another who weighs 200 pounds and lifts the same 200 pounds.
The lighter person is actually stronger relative to their size.
Precisely.
So that makes sense. And I guess that's super important in, like, gymnastics and stuff.
Oh, absolutely. In gymnastics, you need incredible strength, but you also have to be lightweight to, like fly through the air and do all those crazy moves.
Yeah, totally. And I bet it matters in other sports with weight classes too, right?
For sure. Think about boxing or wrestling, where you're competing against people in a specific weight range.
Makes sense. But I'm curious, is this relative strength thing only important for, like, athletes?
Well, it can benefit everyone, really. I mean, think about everyday activities.
Okay, yeah.
Like carrying groceries, climbing stairs, playing with your kids. All of that requires strength.
True. So someone with higher relative strength would probably find those things easier.
Exactly. You'd be able to do more and get less tired, even without necessarily having huge muscles.
Okay, I'm starting to see why this matters. But how does the body actually build this relative strength? The video mentioned the nervous system plays a role.
Oh, yeah. The nervous system is key.
Yeah.
It all starts with, like, a signal from your brain.
So the brain is basically the control center.
Absolutely.
Yeah.
Like, imagine your brain is mission control and your muscles are just waiting for instructions.
Okay, I like that. So when you decide to lift something, that signal shoots out from, what was it, the motor cortex?
The motor cortex, exactly. And then it travels all the way down your spinal cord.
So the spinal cord is like the information superhighway.
Perfect analogy. And the signal zips down this highway through a pathway called the upper motor neuron.
Upper motor neuron, got it. Then what? Does it go straight to the muscle?
Not quite. It first has to connect with another neuron called the lower motor neuron. And this happens at a very specific level in your spinal cord, depending on which muscle is being activated.
Wait, so different muscles have their own, like, designated exits off the spinal cord highway?
Exactly. It's incredibly organized.
Wow, that's so cool. Like, I guess, what if you're doing bicep curls? Where would that signal exit?
For bicep curls, it would be around the C5, C6 level. And for something like squats, which works your quads, it would be more like L2, L4.
L2, L4 for legs, C5, C6 for biceps.
Yeah.
That's amazing. So organized. But how does this signal actually, make the muscle stronger?
Okay, so here's where those motor units come in.
Motor units.
So each of those lower motor neurons connects to a bunch of muscle fibers. And that whole unit, the neuron and all the fibers it controls, that's a motor unit.
Okay, so it's kind of like if the neuron is a light switch and the muscle fibers are the light bulb.
Exactly. To lift something heavy, you need to turn on more light bulbs, or in this case, activate more motor units.
I get it. And the more you train for strength, the better your nervous system gets at recruiting those motor units.
Exactly. It's like becoming a master electrician, figuring out how to power up more and more lights at the same time.
Wow, this is so cool. So it's not just about muscle size, it's about the brain getting better at, like, controlling the muscles you already have.
That's a huge part of it. And there's more. The communication between the neuron and the muscle also gets more efficient with training, which further boosts strength.
Great.
We call this point of connection the neuromuscular junction.
Neuromuscular junction, okay. That sounds pretty important.
Oh, it is. But before we dive into that, how about we take a quick break, and when we come back, we'll explore this tiny but mighty junction and how it helps you get stronger.
Sounds good. We'll be right back after a short break. Okay, so the neuromuscular junction. This is where the neuron and the muscle fiber actually meet.
Yep. Think of it like a tiny gap between the two.
A gap, so they don't actually touch.
No, this gap is called the synaptic cleft. And when that signal from the brain arrives at the end of the neuron,
it has to jump across this gap somehow.
Exactly. And it does this by releasing a special chemical messenger.
Ooh, a chemical messenger. What is it?
It's called acetylcholine.
Acetylcholine. Okay.
And it basically floats across the synaptic cleft and binds to receptors on the muscle fiber.
So it's like a little boat carrying a message across a river?
I like that analogy. And when acetylcholine reaches the other side, it's like a key fitting into a lock.
It unlocks the muscle contraction.
Precisely. It triggers a whole chain reaction inside the muscle fiber, which ultimately leads to the muscle contracting.
This is amazing. But I have to ask, where do those sarcomeres fit into all of this? Remember those tiny contractile units we talked about before the break?
Right. Well, this is where they come into play.
Yeah.
Remember how I said that acetylcholine triggers a chain reaction inside the muscle fiber?
Mm-hmm.
Well, one of the things that happens is the release of calcium.
Okay, calcium. Why is that important?
Calcium plays a crucial role in the actual contraction of the sarcomeres.
Tell me more.
Okay, so inside each sarcomere, you have these two main protein filaments, actin and myosin.
Actin and myosin, right, like tiny little ropes.
Perfect. Now, myosin has these little heads that want to grab onto actin, but there's another protein complex in the way called troponin tropomyosin.
Troponin tropomyosin. Wow, that's a mouthful.
I know, right? Let's just call it TTC for short.
Okay, TTC. So it's blocking the myosin from grabbing the actin.
Exactly. It's like a chaperone keeping them apart.
Haha, I love that. A microscopic chaperone.
But when calcium enters the picture, it binds to TTC, causing it to shift out of the way.
Uh-huh. So calcium is like the cool friend who lets the chaperone slip away for a minute.
Perfect. Now, myosin is free to grab onto actin and pull, which shortens the sarcomere and causes the muscle to contract.
Wow, so it's like a tiny tug-of-war happening inside each muscle fiber. But what gives myosin the energy to keep pulling?
That's where ATP comes in.
ATP, the energy currency of the cell.
Exactly. It's like the fuel that powers this whole microscopic dance.
So ATP allows myosin to detach from actin, reset, and then grab again for another pull.
You got it. And this cycle happens incredibly fast, leading to smooth and powerful muscle contractions.
Okay, this is seriously blowing my mind. So much is happening at this tiny level, but how does all of this relate back to building relative strength?
Great question. So remember we were talking about how training can make the neuromuscular junction more efficient?
Yeah, the neuron getting better at releasing acetylcholine and all that.
Right. Well, training also improves the sensitivity of those receptors on the muscle fiber, so they're better at picking up the acetylcholine signal.
So it's like upgrading your communication system for better signal strength.
Exactly. And on top of that, the processes inside the muscle fiber also get more efficient, like the release of calcium, the binding of myosin to actin, even the way the muscle uses ATP, all of that gets optimized with training.
Wow, so it's like a whole system upgrade.
Absolutely. And that's why you can get significantly stronger without necessarily having your muscles get a whole lot bigger. You're basically making those existing muscle fibers work better.
This is incredible. So it's like fine-tuning a high-performance engine to squeeze out every ounce of power.
Exactly.
Okay, so now I get the connection between the nervous system, the neuromuscular junction, and these amazing sarcomeres. But I'm curious, what kind of training specifically targets these mechanisms?
Well, if you're aiming for relative strength, lifting heavy weights with low reps is key.
Low reps? Like how low are we talking?
Think like 2 to 5 rep ranges. This kind of training really forces your nervous system to adapt and become more efficient at recruiting those motor units.
Okay, so it's like pushing your nervous system to its limits to get those strength gains.
Exactly. And because you're not doing a ton of reps, you're not necessarily triggering those pathways that lead to a lot of muscle growth.
So that's why you can get stronger without getting huge.
Exactly.
That's interesting. But wouldn't it be better to just lift lighter weights for more reps?
It depends on your goals. Lifting lighter weights for higher reps is great for building muscular endurance, but it doesn't target those neurological adaptations in the same way.
So it's like choosing the right tool for the job. Heavy weights, low reps for relative strength.
Exactly. And don't forget the importance of rest, both between sets and between workouts.
Oh yeah, rest is crucial.
Those heavy lifts are demanding on your nervous system, so you need to give it time to recover and adapt.
Makes sense. But what if you hit a point where you just can't lift any heavier?
Well, that's where things get really interesting. The video actually mentioned that eventually you might need to incorporate some hypertrophy-focused training to break through plateaus.
Wait, so adding in some higher rep sets to actually increase muscle size could help you get even stronger?
It can. It's like adding another tool to your strength-building toolbox.
Okay, that makes sense. So even if your primary goal isn't getting bigger, you can still use hypertrophy training strategically to reach new levels of strength.
Exactly.
Wow, so we've covered a lot of ground here. The nervous system, motor units, neuromuscular junctions, sarcomeres, different training approaches. It's a lot to take in.
It is, but hopefully it gives you a deeper appreciation for just how incredible the human body is.
It definitely does. And even though we've been talking a lot about the science behind all of this, I can't help but feel like there's something almost magical about the way our bodies can adapt and get stronger.
Oh, absolutely. There's still so much that we don't fully understand about how all these processes work together.
Right. Like we're still just scratching the surface. But that's what makes it so fascinating. And it makes me wonder, like, what other secrets are hidden within our cells, just waiting to be unlocked?
That's a great question. And it leads perfectly into what I wanted to ask you. Now that you have a better understanding of these different pathways to strength, what kind of training approach are you thinking about trying?
That's a good one. Well, what about you all listening? Are you intrigued by the idea of getting seriously strong without getting huge? Or maybe you're thinking about incorporating some hypertrophy training too.
There's no one right answer. It all depends on your goals and what you enjoy doing.
Exactly. And that's what I love about this. We're not talking about some rigid set of rules. It's about understanding how your body works and making informed choices about your training.
Absolutely. And even beyond the specifics of training, I think the biggest takeaway here is the sheer possibility.
What do you mean?
I mean, you can significantly increase your strength, and it doesn't have to involve those drastic outward changes that we often associate with strength training.
It's like a secret superpower, building inner strength that translates to like greater resilience and confidence in all areas of life.
Exactly. And on that note, I'll leave you with one final thought to ponder. What goals could you achieve by focusing on building relative strength? It could be anything from dominating a fitness challenge to simply feeling more energized and capable in your daily life.
That's such a great question to reflect on. So keep exploring, keep pushing your boundaries, and keep diving deep into the amazing world of human potential. Until next time.
Yeah, it really does make you wonder what else we could accomplish if we really focused on tapping into this, like, hidden potential.
Right. Like we often focus so much on the external changes, but there's this whole inner world of strength and resilience that we can cultivate too.
And it's not just about aesthetics, it's about function, right? Like being able to move through the world with more ease and confidence. Exactly. And that can have such a ripple effect on every aspect of your life.
Thinking about all of this makes me wonder, now that you have a better understanding of these different pathways to strength, what goals could you achieve by focusing on building relative strength?
Ooh, that's a great question. It could be anything from, like, finally conquering that challenging hike you've always wanted to do, to just feeling more energetic and capable in your daily life, right? What about you all listening? What goals come to mind for you?
I think that's such a powerful question to reflect on because it really highlights how this knowledge can translate into real-world results.
It's not just about lifting heavier weights in the gym. It's about feeling more empowered in every aspect of your life. And that's what I find so inspiring about this whole concept of relative strength.
Me too. It's like unlocking a hidden superpower that you didn't even know you had. Exactly. Well, on that note, I think it's time to wrap up this deep dive. But before we go, I just want to say a huge thank you to the listener who sent in that amazing video from the Institute of Human Anatomy. You totally sparked a fascinating conversation.
Yes, thank you so much for sharing that with us. It's been a pleasure diving into this topic with you.
And to everyone listening, keep exploring, keep pushing your boundaries, and keep diving deep into the amazing world of human potential. We'll see you next time.